Okay, welcome back to Mr. Hassan's Maths channel. In this video, I'm going to go through question number 10 from the old Edexcel C1 paper from January 2012. It's still relevant to the P1 syllabus, so I'm going to go through this question as requested by one of my students. This is question number 10 from that paper, and it's a question that tells us about a curve, the sketch of a curve C, which is the curve part here. And it has the equation y equals 2 minus 1 over x. So the equation of this curve is y equals 2 minus 1 over x, and of course x can't be 0, otherwise it will be undefined, and that's the asymptote there. The curve crosses the x-axis at the point A, right over there. Find the coordinates of A. Okay, that's pretty simple. We know that on the x-axis all the y values are 0. In fact, its equation is y equals 0, just as the equation of the y-axis is x equals 0. So everywhere on the x-axis y is equal to 0. So if we substitute y equals 0 into this equation, it will tell us where it crosses the x-axis. So all I need to do is to substitute. We can say at A, we can say y must equal 0. So we can say that 2 minus 1 over x is equal to 0. So 2 is equal to 1 over x, and if we cross multiply here, we can just multiply both sides by x and divide both sides by 2 at the same time. We have x equals a half. So that's the x coordinate of A, and of course the y coordinate of A is 0. So A is going to be the coordinates a half and 0. So that's simple enough for part A. Now part B tells us to show that the equation of the normal to C at A can be written as 2x plus 8y minus 1 equals 0. So basically we got to find the equation of the normal to C at A. So A is the point, as we said, a half and 0. So the equation of the normal. Now a normal to a curve is a straight line which is perpendicular to the tangent of the curve. So the tangent to a curve is again a straight line, but it's a line which just brushes the curve at the point at which it's the tangent to it. So the tangent to A will be a line that goes something like this. It will just brush past A, okay, and it has the same gradient as A, as the curve at A, and this is the tangent. This is the tangent. Okay, we can call this the tangent. Okay, at A, and this here is a normal. This is normal to the curve at A. Okay, so the normal is perpendicular to the tangent. The normal is perpendicular to the tangent. It hits at right angles. So we've been asked to find the equation of this normal. Okay, to find the equation of a straight line, we need two things. We need to have any point on the line, which we have, which is A, which is a half 0, which we found already, and we need to know the gradient of the line. So I need to know the gradient of this normal. I need to find the gradient of this normal, and then I can find its equation because I already have a point on it. However, to find the equation, to find the tangent of the normal, to find the gradient of the normal, we need to find the gradient of the tangent first, because that's what we can find, because the gradient of the tangent is the same gradient as the gradient of the curve at the point where it touches it. So if I can find the gradient of the curve at the point A, that means I found the gradient of the tangent at the point A, which means I can therefore find the gradient of the normal at the point A, which will be perpendicular to the gradient of the tangent. So our first objective, therefore, is to find the gradient of the curve C at the point A. That's what's going to help us. So a straight line. We know the normal is a straight line. We need two things. We need a point on the line, which we have. This is, let's put that there. That's one of the things we need. So we have a point on the line. The second thing is we need the gradient of the normal. We need the gradient of the normal to the curve at A. Normal at A. Okay, so to find that, we have to first find the gradient of the tangent at A. So the gradient of let's find the gradient of the curve at A. Gradient of C at A. Okay, so we have to find the gradient function. So y equals 2 minus 1 over x. Now dy dx is a gradient function. When I differentiate this, I get what's called the gradient function. So when you differentiate this, you get 2. Well, first of all, let's get it ready for differentiation. Let's move it up there a bit. Before we differentiate it, we can write this as 2 minus x to the power of minus 1. So the denominator is not in index form, write it in index form. And dy dx, well, this becomes 0 when you differentiate a constant, and you have to multiply by the power. So minus 1 times plus 1 is basically, sorry, minus 1 times minus 1 is plus 1, and then you do x to the power of negative 2. So you multiply by the power and take 1 from the power, so you end up with x to the power of minus 2. So therefore we can say the gradient function dy dx equals 1 over x squared. So at a, we know that x is equal to a half, so we can say that dy dx is equal to 1 over a half squared, which is 4. 1 over a quarter, which is 4. So we know the gradient of the tangent is equal to 4, okay, at a. Therefore the gradient of the normal is equal to the negative reciprocal. When you have two lines which are perpendicular, the gradients are negative reciprocals of each other. So this is like 4 over 1, so it becomes a minus negative reciprocal 1 over 4. So I know that I have enough information now to find the equation of the line of the normal. I know the gradient of the normal, I know a point that it passes through, so I can use y minus y1 equals m times x minus x1. So I have y minus 0 equals m, which is minus a quarter, times x minus a half. Okay, so I can multiply both sides of this equation by 4 first. So I'll have 4y is equal to minus x plus a half, and I can multiply again by 2. So I have 8y equals, if I multiply by 2, I'm going to have minus 2x plus 1, and therefore we can write the equation as requested. I think it was minus 2x plus 8y minus 1, exactly what we're going to get. If we bring the everything to the left side, you have plus 2x, you have 2x, because you have to add 2x to both sides. So you have 2x plus 8y minus 1 equals 0. So there we have the equation as required in the question we had to show. Okay, next we have to do the next part of the question, where it tells us that the normal to C at A meets C again at the point B. So the normal that we just found the equation for, it meets the curve again at the point B, as shown in figure 2. Find the coordinates of B. So I have to find out basically where does the normal hit the curve. Okay, we already know one point, we got to find the other point. Okay, so what I'm going to do here, I'm just going to take these two, I'll take these two equations together on the other side of the page, because I have to solve these two simultaneously basically. That's what I have to do. I have to solve these two equations simultaneously. Oops, it comes out really big, doesn't it? Let me just put them smaller. Okay, so I'm going to just put this smaller. So I have to find the solution to these two equations simultaneously. That's what I have to do. Okay, now in order for me to do that, let me put it over here. In order for me to do that, I can use substitution here. Okay, because I have two equations. I guess I could make y the subject of both of them, but I think it would be easy for me if I just replace the y here with 2 minus 1 over x. Then I would find where they intersect. If I solve these simultaneously, if I substitute one equation into the other, I find where they intersect. Okay, so what I'm going to do is I'm going to replace this y with 2 minus 1 over x. So I have 2x plus 8. Instead of y, I'm going to put 2 minus 1 over x, and then I've got minus 1 equals 0. So 2x plus 8y minus 1 equals 0. And now we have everything in terms of x, and I can solve this for x. So first of all, let me just simplify a bit. 2x plus 16 minus 8 over x minus 1 equals 0. So I'll have 2x, 16 minus 1 is plus 15, minus 8 over x equals 0. I want to solve this equation, so I want to get rid of the fraction. So let me multiply both sides of the equation by x to get rid of the fraction. So I'm going to get 2x squared plus 15x minus 8 equals 0. Now I have to solve this quadratic equation. I actually know one of the solutions is x equals a half, because we know that this is where the point A is. A is a point a half 0. So I can be, when I factorize this, I can be sure that I'm on the right tracks if I get one of the answers as x equals a half. Okay, now I'm going to factorize this. So I've got my 2x squared here, and I got my minus 8 here. So I find two numbers that multiply to give you, so the product is negative 16x squared, and the sum is plus 15x. Okay, so I think that must be 16 and 1, so it must be 16 and minus 1. So I'm going to have 16x here and minus x there. Those multiply to give you the same as these, and when I add them I get plus 15x. That's correct. So let me take out the common factor from these two is 2x. 2x times 1x is 2x squared. 2x times plus 8 is 16x, and x times minus 1 is x. Minus x, sorry. So I end up with my solution as 2x minus 1 times x plus 8 equals 0. So if we see here from this that x equals a half, we know that already. So I kind of can be quite sure that I'm on the right track, because I found the point of intersection is a half, which we know already for one of them. That's for A. So that means this must be for B. So we need to find it tells us to find the coordinates of B. Okay, so the coordinates means a y coordinate as well. So don't just stop there. So we know that the equations are as follows. I can use either of these two equations. Okay, I could use this equation or that equation when I know x equals minus 8. I think this is a bit easier to use, to be honest. Yeah, either of them is fine. I'll just use this because it's already in terms of y. So y equals 2 minus 1 over x. So we know that y equals 2 minus 1 over x. And we know that x equals negative 8. So you've got 2 minus basically 1 over negative 8, which is going to give you 2 plus 1 over 8 basically, which is going to be 16 over 8 plus 1 over 17 over 8 as a fraction. So our coordinates of the point B are negative 8 and 17 over 8. Those are the coordinates of B, and that is the end of the question. I hope that was clear. I'm going to put other questions from this paper, January 2012, C1, in this playlist here if I get to answer any more. And I'm also going to put the P1 paper playlist up here from which I took this question for. And I will also have questions to do with differentiation from C1, in fact P1. I'll put that in one of the playlists, as well as my subscribe button, and as well as a card taking you to one of the P1 papers that I have already answered of the new syllabus. So I hope you understood, and I hope to see you again soon. Thank you for watching.